Hi and welcome to this video on statistics. Statistics is the study, collection, analysis, interpretation, presentation and organization of data. Ideally, we'd like to survey the whole population. This is called a census, but not easy to do, so what we do is sampling. And a representative sample, the conclusions we draw from that can be safely extended from the sample to the population as a whole. So we're going to be collecting data. This can be primary data, secondary data. The data can be qualitative, it can be quantitative. Then we're going to interpret the data and present the data in a form that's easily understood. These words, primary, secondary, qualitative and quantitative, important words that you need to know, and we'll go over that later. When we're sampling, this can be random sampling, where we select individuals at random. We assign random numbers to people or objects using a calculator or a computer. And then if we're going to sample 20 people or 20 objects, we take the first 20 numbers, and that's our random sample. In systematic sampling, we start with a random selection and then select every 10th or every 15th person or object at regular intervals, and that's our random sample. In stratified sampling, we have a selection of groups or strata, then we pick at random from that group, and that's our sample. In quota sampling, we try to pick a sample which reflects the population, like if the population or the objects are in small groups, we pick a small group that represents the total population. Just going to go over stratified sampling because you can be asked questions on this in the exam. Here the population is divided into groups or strata. The researcher takes a sample from each stratum. This guards against unrepresentative sampling. The sample is quite small, or can be quite small, and is representative of the whole population. One disadvantage is that it requires more administration. This type of sampling requires more administration. We want a sample of 20 children out of a school of 500. The different years would be the layers or the strata. Year 1, there's 180 children, so we need to know how many children we need to take from that year. So the researcher wants 20 out of a total of 500 children in the school. For year 1, then the sample size would be 20 divided by 500 times 180. This gives us the number of children from that year that we need. Repeat for each layer or each year, and that gives us our representative sample of 20. When we're collecting data, this can be primary data. Primary data is collected by the researchers themselves through interviews, observation, questionnaires, research. Questionnaires are practical and cost-effective. They can be quantified, can be analyzed scientifically and objectively. The disadvantages are that it's difficult to tell if the respondent is being truthful. The respondent may be forgetful. People read the questions differently, and there's always that the researcher has already made a decision on what's important when they're writing the questionnaire. When we're collecting data, that it can be secondary data. Secondary data is data that already exists from previous research, official statistics, diaries, letters, and historical data. Sample data can be qualitative, quantitative, continuous or discrete. Again, these are words that we need to know or know the definitions of. Qualitative data is non-numerical, like a color, red, blue, long, short, so that's qualitative data. Quantitative data is numerical data, like length, age, time, numbers of things, so it's a number. Continuous data has a given range, say like age, which is 10 to 15 years, 15 to 20 years, so it has a range. And discrete data has certain values only, such as shoe size, cost. When we're doing our survey for getting our primary data, then we have to keep the questions simple so they can be interpreted the same by everyone. The boxes there has to be a minimum of 3 boxes. The question should include a time frame, very important that, a time frame. Responses should cover all options so that the person doing the questionnaire has to tick a box. So every possible answer should be covered. The responses shouldn't overlap so that you tick more than one box. Don't use leading questions, don't use personal questions, and avoid biased terms or wording. It's best to use open-ended questions. Okay, now we're going to do a survey of popular car colours. So standing on a street corner for 5 minutes and noting down these popular red, blue, silver, white, which are popular colours for cars. We make a tally, so every time a red car goes past, make a little tick. A blue car goes past, make a little tick. At the end of our allotted time, we stop and then write down the frequencies 2, 6, 4, 3 by counting out the ticks. Then a cumulative frequency is the frequencies added in order. So first frequency, cumulative frequency would be 2, 2, and then add 6 is 8, 8 add 4 is 12, 12 add 3 is 15. This 15, this right at the bottom, tells us the total number of cars counted in that time. So that's cumulative frequency. Relative frequency is the frequency divided by the number of observations. Percentage frequency is relative frequency multiplied by 100. We can then show this data in the form of a bar chart. A bar chart has the number of cars or the number scale on the vertical axis, and then the qualitative things on the x-axis, on the horizontal axis. So on the horizontal axis we've got red car, blue car, silver car, white car. The bars that we draw are always equal in width, and the height represents the number of cars. So here we have 2 red cars, 6 blue cars, 4 silver cars, 3 white cars. Bars aren't joined together, they're separate. Here we've got the same information in the form of a pie chart, where the colours are representing the colours of the cars counted. It's good for representing proportions, displaying percentage distribution. It's easy to read, and the size of the slice, say here the white cars, the size of the slice represents the percentage size, so it's visually quite good. We can see at a glance the different sort of percentages or percentage distribution. Can be asked how to find this angle for one of the slices, so this angle for a blue slice, and we're given this information that the total cars on the road are 200 and the blue cars 82. So the total degrees in a circle is 360. So 200 cars equals 360 degrees. So write that down as like this. So 360 equals 200. We need to know the number of degrees, write that under the 360, and that would equal 82 cars. So our fraction would be 82 divided by 200, and then we multiply that by 360, and that gives us the number of degrees for that slice within the pie. If we're given the question in this form, given that red cars are 19% of the total, we write 100% is equal to 200 cars. So underneath 100% write 19 equals question mark, which would be the number of cars. Our fraction would be 19 divided by 100 and multiply that by 200, and that equals the number of red cars. Similar values, say there were 4 similar values, the pie would just be divided into 4, and visually it wouldn't be very good at showing differences in percentage size. Scatter graphs can be asked this in exams, so just going to go over it quickly. Scatter graphs show how closely two things are related. So we have one thing on the vertical axis and another thing on the horizontal axis. Be careful when you're choosing the axis and the scales. So here, say we're doing hours of exercise and the resting heart rate. So as we can see, as we increase the hours of exercise, the resting heart rate decreases. All these little points that we've plotted are going down, so we can draw a line between them. The line that we draw has to be a line of best fits, goes through as many points as possible, but if we can't do that, then an equal number of points below and above the line. When the line goes downhill, we call that a negative correlation, but be careful again, because the hours of exercise and resting heart rate is a good thing, shows that you're fit. It's not necessarily a bad thing, although the correlation is negative. Here the line goes upwards. This is a positive correlation. If there was no correlation, the points would be here, 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 and we wouldn't be able to draw a line. There would be no line that we can draw through and have a straight line. Frequency tables, we're often given these in an exam. A frequency table, here we're going to do number of brothers. So we have 0, 1, 2, 3, 4, 5, 6 brothers, and number of people that have that many brothers. So 7 people have no brothers, 15 people have 1 brother, 12 people have 2 brothers. And then this third row is the frequency times the number of brothers. We do that, and then this is the total number of brothers, so we have 80 brothers, and this is the number of people asked. Just going to go over what we mean by mean, median, mode, and range. So the mean is the average, so that's the total divided by the number of people asked. So the total brothers is 80. The number of people asked 46, 80 divided by 46, 1.74. Median is the middle, which out of 46 people would be the 23rd person, and that would be 2. The mode is the most frequent, so the most frequent here is 15, so that'd be 1. And the range would be from 0 to 5, because for 6 there's 0 people. So the range in this case is 5 minus 0, which is 5. Stem and leaf plots, again used for quantitative data. So all these things we've done so far are for quantitative data. So numbers are being used rather than qualitative data like height or age with a range. So this is for quantitative data with 2-digit data. This set that we've been given has 15 elements, so 22, 24, 27, 25. First of all, if we're given this in an exam, arrange it as you're given the data set. So the stem is the number of tens and the leaf is the number of units. So this represents 22. This represents 24, 27, so we're going through and writing the numbers so. So the key, which you always have to write down, the 2, a line, and a 5 represents 25. So first of all, write it in the order that you're given, and then write it in numerical order, place value according to the key. So we'd go from here, put the 2, 3, 4, 5, 6 as the stem, and then write this in numerical order. So this would be 22, 24, 25, 27, 31, 32, 33, 35, 39. So we've gone all through those numbers. Advantage is you can spot easily the common scores with the stem and leaf plot. and spot extreme values and outliers. You can group the data easily. This shape, as we go over the top of the data, is a positive skew. So all the data is towards the lower end of the scale, and if it was towards the higher end of the scale, the larger value of numbers, we'd call that a negative skew. So if the shape was like this, as in this case, that's a positive skew. If the shape started here and then went up like that, that'd be a negative skew. Again, let's revise mode, median, range, and mean. Mode is the most common value. So here it's 45 appears twice. That's the mode, 45. Median is the middle value. So the middle value of 15 elements would be between the 7th and the 8th. So it'd be the 8th. So 7 on one side, 7 on the other. So 8 would be in the middle. So that's 35. The range, highest value minus the lowest value. So the highest value is 64, lowest value is 22. 64 minus 22 is 42. The mean would be the average, so we add all these 15 numbers and divide by 15, and that gives us the mean. So that's stem and leaf plots. The next lot of data that we're going to use is quantitative data, which is continuous data as well. So here, class boundaries are important. Class boundaries usually end with 0.5, and it's where we pass from one group to another group. So here our class boundary would be 30.5, here it would be 40.5, here it would be 50.5, 60.5, 70.5. And then mid-interval values, they're again usually 0.5 something. So our mid-interval value is the middle between 21 and 30, which is 25.5. The middle 31 and 40, 35.5, and so forth. And then this column is the mid value multiplied by the frequency. So 244 multiplied by 25.5, 204. 35.5 multiplied by 16, 568. Now, because we've got a range of values, we can't get an exact mean, so we have to have an estimated mean. And the estimated mean is this total of the frequency multiplied by the mid value divided by the total of the frequency. So that's 2650 divided by 60, which is 41.6. The mode, which is the middle value, would be 41 to 50 kg, and an estimate of the median would be between the 30th and the 31st entry. So the middle of 60 is between 30 and 31, and that lies, when we count up here, 8 plus 16, it lies in this group, which is 41 to 50 kg. We can draw a cumulative frequency chart or a diagram or graph. We do this by having our weights, which are range, quantitative data. So we have the frequencies of people with those weights. Then the cumulative frequency, so 8, 16, so 8 plus 16, 24, 24 plus 16, 42, and so forth. So we add these together. So 8 plus 16, and that total plus 18, that total plus 12, that total plus 6. That gives us our cumulative frequency. And then we have our, as from the previous group, we discussed our class boundaries. So class boundaries 30.5, 40.5, 50.5, 60.5, and 70.5. Cumulative frequency is the running total of the frequency, and then we always plot the highest value of the group against the class boundary. So we would always plot the highest value of the group against 30.5. So here we'd have 30.5, and then the cumulative frequency we'd have 40.5, and then that cumulative frequency. So that's how we get this S-shaped curve. This is a typical cumulative frequency curve, has an S shape. You can join the points with straight lines, that's allowed, but usually we draw it as a curve. It's better to draw it as a curve. Now we've got our cumulative frequency curve. Right at the top, we take a line across, or an arrow across, and this gives us our total for our cumulative frequency, this total here, which is 60. We divide 60 by 2, take our arrow across to the curve and go down, and this is our mean. Sorry, this is our median. So that's the middle. So 60 divided by 2, middle, which is median. So that's exactly halfway up between 0 and 60. So 60 divided by 2 is 30. So total cumulative frequency, median. Then between our median and our total cumulative frequency, exactly halfway between, is our upper quartile. So take that across to the curve, line across to the curve, and down and read off the weight. And then between the median and 0 is our lower quartile. So line across to the curve and down and read off. So that's our lower quartile weight. So the total was 60. The median, so that was at 70.5. The median 43 kg. The upper quartile, read off here, at 52 kg, and the lower quartile 39 kg. The interquartile range is this distance here, the upper quartile minus the lower quartile, which is 13 kg. Box and whisker diagrams we can draw from the cumulative frequency diagram. So we drop down lines from the total, from the upper quartile, from the median, and from the lower quartile and the lowest value, and then a box. This is the line representing the lower quartile, line representing the upper quartile, the median in the middle of that, and then draw a box around it, and lines across to the upper value, a line across to the lower value. So this is called a box and whisker diagram. This is the box. This side of the box on the lower scale is the lower quartile. This side of the box is the upper quartile, and the line in between represents the median. This is the lowest value. This is the highest value. And from here to here is the interquartile range. The interquartile range is a measure of the spread or dispersion around the median. If the box was towards this side, towards the lower numbers, this we call a positive skew, and if this box was towards the higher numbers, if it was over here, this we call a negative skew. Histograms. Here I've drawn a histogram using this data here. Histograms are like bar charts, but they don't have spaces between the bars. Along the bottom we have the range of numbers, so from 3 to 33. 10 numbers fall between the range 3 to 9. 2 numbers fall between the range 9 to 15. 2 numbers fall between the range 15 to 21. 1 between 21 and 27, and 1 between 27 and 33. So this is the range. This is the class width from 3 to 9, 9 to 15. So the class width is 6 in each case. And the height represents the frequency in this case. In histograms, the area of the rectangles, or the area of the bars, is proportional to the corresponding frequencies, and the shape of the graph shows how the numbers are distributed about the mean. Sometimes can be asked to draw a frequency polygon. So a frequency polygon, we take from our frequency histogram the midpoints of our range, or our various ranges. So plot the midpoints and join them with straight lines, and that gives us our frequency polygon. Really important in the exams, histograms and frequency density. Can be asked questions on this because it involves knowing about the areas of the graphs and about class widths and things that are quite important and that can be calculated. So in our table of ages of people at a fun fair, we're given that 30 people have an age between 0 to 15, 28 people have an age between 16 to 25, 18 people have an age between 26 to 40, 30 people have an age between 41 to 60, and 6 people 61 to 100. This is the class width, so this row on the table represents class width. So 0 to 15, that's 15, 16 to 25, that's 25, that's 10, 26 to 40, 15, 41 to 60, 20, 61 to 100, 40. So that's our class width. Then our frequency density is our class width divided by the frequency. So that's 30 divided by 15 is 2, 28 divided by 10 is 2.8, 18 divided by 15 1.2, 30 divided by 20 is 1.5, and 6 divided by 40 0.15. Then this is our age scale, our scale demonstrating our age. So we have each one of these squares is 20, so we have 20, 40, 60, 80, 100, so 0 to 100. Then we mark on our class width, so this is 0 to 15, 15 to 26, so 15 to 25, sorry, 26 to 40, 41 to 60, and 61 to 100. Then we mark our frequency densities, so here it's 2, 2.8, 1.2, 1.5, and 0.15, and then draw our vertical lines to make bars which are joined together. And remember, the area of these bars is proportional to the frequency. The vertical line is always the frequency density, horizontal line is age, and these are our class widths on the bottom. If we're given that this bar from 26 to 40 represents 18 people, count how many units there are within that, and by units we measure the up, so that would, here it's up to 24 and 7.5 across. So don't use this scale that we're given, count the number of units, so these little squares within. So 7.5 times 24 is 180. 180 represented 18 units, so 180 divided by 18 is 10. So each person is represented by 10 units. To calculate the estimated mean, we get the frequency, so that's the number of people, so that we calculate, and multiply by the midpoint, so we need to find these midpoints of the class widths, so the midpoint here, 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 and here, and then divide that by the total number of people. So we found that the area of the bar that we were given here between 26 to 40 was 7.5 times 24 units. That was 180 units. Divided that by 18. We got that 10 units is one person. Do that for each bar. For the 0 to 15 bar, it's 40 units up. So each one of these is 10, 10, 20, 30, 40 units. And 7.5 across, so that's 300. 300 divided by 10 is 30 people. So we do that for each bar. We're already given this 18. So this bar we calculate as 28. This one is 30 people, and this one as 6 people. Then to estimate the mean, write the numbers in the bar. So this would be 30, 28, 18, 30, and 6. To estimate the mean, or get an estimated mean, we get the midpoint. So the midpoint here would be 7.5. The midpoint here would be 20, 32.5, 50, and 80. Multiply that by the number of people, and we get 225, 560, 585, 1,500, 480. The total of that is 3,350. The total number, or these numbers added together, is 112. 3,350 divided by 112, 29.91 years.